Uh-oh. Are we live? I think we are, but I have to double check that and make sure that my audio is not completely whack. Let's see. Alright, looks like we are live. We are, but I have to double check that. Alright, looks like we are live. I think we're just gonna jump right into it. Per the title, we are moving forward in our Kubernetes journey, understanding the fundamentals as a software engineer who, I guess, doesn't want to be completely ignorant about what it's like to just deploy something out there. And I know Kubernetes is not like you can deploy stuff without ever learning or knowing anything about Kubernetes. But at some point, if the reality is Kubernetes is, whether people love it or hate it, it's the king of just deploying applications that actually make money. Like serious money. I'm not talking about some, well, okay, I should be careful in how I phrase this. You don't have to learn or know Kubernetes in order to build software and deploy it and make, a whole lot of money out of it. I'm just saying that some of the biggest systems that are running today heavily rely on Kubernetes. And so if as a software engineer you're always interested in understanding how things work, especially at scale, what it takes to deploy these services and keep them running, and just the complexity of infrastructure, just dipping your toe into that a little bit, I think knowing Kubernetes is sort of kind of a prerequisite, I think, so that you're not completely clueless, basically. Yeah, so part 3, I think part 1 was very introductory. Part 2, we did I think we did the Minikube cluster setup just to get basic familiarity with it. And today we are going to go through the deploy an app section. And yeah, that's the plan for this stream. Doesn't seem to be that involved, so we'll go through it. To get started, I think we need to do to get a Kubernetes cluster up and running again like we did last time. And I think we can just follow again the steps that we went through in the second part or the second stream. So I think it's Minikube start. Ooh, okay, it begins. What happened? Am I on the wrong? Uh-oh, what did I do? Shoot. I think I may have screwed up my my brew installation, because this is my secondary account on this laptop, and it's possible that I did something in the primary account that screwed things up here. Well, this is annoying. Probably should have double checked on this before starting the stream. Oh, now I'm not sure what to do. Can I just install it? Gosh, I do not. I feel like I really don't want to go through this whole Minikube install again. But it sounds like that's what I'm gonna have to do. In theory, what I could do is just go through the video from last time and try to reproduce the install that I did. Yep, we are live. Okay, let's actually try that. This whole Nix account managing and stuff, I'm not loving it. Okay. Part of it is my own fault. Part of it is just it's not as the Nix experience is not as let's get it going friendly as I hoped. Yesterday we did, and I mean I've read some cautionary, I guess you can call them cautionary tales about how it's nice when you can get it to work, right? But the overall experience can be kind of terrible unless you've really experienced and you've worked with it for a long time and you have a particular way of doing things that works consistently and all that. And I'm definitely not at that point yet with that tool. So I don't know. I'm not feeling the great vibes in terms of the user experience so far. Anyway, our very initial intro to the Kubernetes. That's what it was. Yeah. The controller manager. Kubelabs. Something I need Docker. Isn't there like a Docker alternative that I can use from Mac? Yeah, we went through this whole thing. What did we end up installing? Was it Podman? Is that a Podman? Oh, this one. Oh, still stuff open from yesterday. Yeah, but I don't want to close them. This is how. Where am I? Okay. And what did it say just now? Spelling? It's 1L. Okay, so it sounds like I ended up what did I end up doing? Okay, so there was no Docker, and so I installed. It's 1L. I installed Colima. Just that one now installed. I'll show one more so you can just run. First of all, let's see what just. Okay, so it's installed. Should I do this? I'm gonna copy this. Oh, just for now. Okay, so wait. Oh yeah, it's there. Okay. Here. Should I do the thing of you know what, I can just put it here if I have a use for that command later. Oh. figure it out. Yeah, because I remember we ran into some issue. Yeah, I think what I need to do is because this is gonna be super annoying. I don't like the idea of going through this whole process again and running into the same issues and trying to fix them. So let's install Minikube. Wait, can I just do this via brew? Brew install Minikube. Right, that's the right spelling. Okay, seems like we are good with the Minikube. Alright. Okay, start your cluster. Wait, is this part of the... No, I think this is the part where I have it installed. Before you begin, is to install Kubernetes. Let's copy this over first. Just for the sake of consistency, I guess, or whatever. Kuro, that's how you spell it, right? What? It's already installed? Oh, when did I do that? Okay. Yeah, I did that in the other account, so it's there. Wait, which version do I have installed? Yeah, it's... One... Well, what's the latest version? Need to reinstall Kuro, okay. So which version? It's the same version. Cube. Yep, okay. Just figuring stuff out, I guess. Which Kuro? Well, I guess it does tell me in the help thing. You can just do a version. Okay. Alright. You're doing the thing. And the yak shaving begins. Alright, I think what I'm gonna... Okay, actually, let me double check. Do I even have Docker? Do I have lazy Docker? Just curious. Yes, I do. Is the Docker daemon running? No, it's not. Okay. Yeah, let's just do brew install. Probably just gonna delete this again later. So this is all to your user, except I don't really want to though. But I don't have a choice if I want to move on with this. I really need to do the proper setup on this secondary account on this laptop, because it's starting to really, and most of it's just laziness and not getting around to it and just not having time. Yeah, okay. And then oh, oh, it's not even connected. All right. Okay. Okay. So the goal right now is to get Docker installed. Permission denied. Yeah, I'm sure this has something to do with And it's still installed. I don't know if that means it will work. Bro, install minikube. Yeah, permissions are being denied left and right. Minikube. Oh, okay, well that did not work at all. Yeah, this is all fucked. I think the only way for me to okay, it's not wait, but it's okay. Minikube not found. So yeah, I mean it's installed, but I think even if I try this, it won't work. Yeah. I think what I have to do is gosh, this is annoying. I should double check this. I need to do this. Don't wanna do this on stream because the other account is my personal account and I'd rather not expose that to streaming activities just in general. How about we just for this session, instead of actually going through the reading the manual, let's see if there is something interesting that we can just look into that's Kubernetes related. Understanding Kubernetes networking, that could be good. Don't want it to be too long though. I wonder if this video is one of those where it's very shallow, it doesn't actually teach you anything specific. Also, I don't know, this particular one, this course might be interesting to go through at some point. Something kind of straightforward that we can just watch to get some fundamental familiarity with Kubernetes, which means I need to change the title. because we're not really reading the manual anymore. Let me try and do that. Kubernetes, which edit video. A small detour from reading the manual. Because I don't. I think you're supposed to add videos of the stuff you've watched. Maybe we'll add this. Kubernetes explained. Watch this. I'll give this a try. Typecraft, I think he tends to have, well, his stuff is good. What else? Let's just find one more. Blah, 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 blah. Anything else? Or do we have enough stuff to cover just for today's stream until I get my shit together and figure out my local setup on this account? Until, next stream where we actually do part 3 of reading the manual. So this is kind of a filler episode as far as not actively reading the actual manual, but I still want to make it useful or interesting or something to learn from, just in general. Okay, well, I think we'll just do with what we have. So there's
everyone,
this.
thank you for coming today.
Let's see what is
Now that we have an understanding of some of the Kubernetes history and how the system components function so effectively. Finally,
I don't know.
For the past 12 months, I've been running my own
assuming
home
that you
lab,
have
using it to self-host a
intermediate-
number of different software and services. My original...
Okay, I think I'm trying
Hey
to figure
everyone,
out
Travis
the
here from
order. I think we'll go with this first. Excuse me. We can close this. We'll go with this first. Then, we can close this. We'll go with this.
For the longest time, Docker was a tool.
And maybe we'll start with this actually. I think this is a good. Yeah, let's do that. All right. So I'm gonna add this video. We are not. Okay. We are checking out links to videos on Docker or Kubernetes. Yeah, that should be enough. So there's this. Okay. All right.
Tool that I used sparingly throughout my whole career. I mean, I'm a Ruby on Rails dev. I don't have to know Docker. I can just run all my services locally on my machine, right? I can even remember throughout my career, if anyone ever mentioned that we needed to use Docker to run something, I would always say, Docker, barely even know her. And as hilarious as that joke is, I was missing out on a core foundational piece of technology that I should have known about all along. In this video, we're going to cover virtualization and containerization and what the difference is between the two things, because for me, this was always messed up in my head. We're also going to cover Docker files, images, Docker containers, and how they all fit into the grand scheme of Docker. This video is going to be a gentle introduction to Docker, and we're just going to be scratching the surface. So stick around. This is going to be a fun one.
Okay, let's speed this up.
So why is Docker an important thing to learn in the first place? Well, you see, you probably use containers and containerization technologies every single day of your career if you're a web developer, even if you don't realize it. Containers are a way to build reproducible, lightweight environments for processes to run, and we use them everywhere in continuous integration and continuous deployment pipelines like on GitHub Actions that you probably use all the time, and we also use it whenever you're deploying to a server. If you deploy something to the cloud, chances are you're interacting with container technology somewhere along the way. So I think it's a pivotal thing that you need to learn in your web development career. But wait, what the hell is a container anyways? In order to talk about containers, we should talk about virtualization. Now bear with me for a minute because these two things are very closely related, and I think it's important to understand the distinctions between the two technologies. So let's talk about virtualization. So let's draw up how virtualization works in a typical sense, and we can talk through it. Now typically, when it comes to virtualization, you start off with a host machine. This could be your host. Now the host could be anything. It could be your local PC, it could be a server up in the cloud, server in a data center somewhere, whatever it is, it's a piece of hardware. Now in this piece of hardware, you have different things that control how this hardware works. You have things like your CPU, you also have things like memory, and you have your hard drive. We'll call this I/O. Now when it comes to virtualization, what happens is we take little pieces of each of these pieces of hardware and separate them out into a separate machine. This is a virtual machine. And then we take these pieces of hardware, and in this virtual machine, we actually run a full entire operating system. Now this technique is commonly used in the cloud if you're deploying something to AWS.
Yeah, and if you think about it, if we couldn't do this, the whole cloud model just kind of falls apart. Like when, like, just imagine if AWS had to basically have a separate physical machine for each freaking account. Well, it's actually worse than that. It's not just each account, but it's also, like, if you think about AWS Lambda, because within the same account you may have different applications that use different Lambda functions, and for XYZ reasons you may not want both to, like, you may not want both to run on the same machine, like XYZ reasons. Anyway, the point is that if there was no such thing as virtualization, the economics of the cloud really doesn't work. Like, I don't, like, a service like AWS Slim that simply doesn't work, or a service like Cloudflare Workers, or all those services where they provide you with, you know, serverless functions, or even just your virtual EC2 instance, right? It wouldn't work if virtualization was not a thing.
Or an EC2 instance, typically what you're doing is you're spinning up a new virtual machine that you can then deploy your code onto. Now, virtual machines have a special type of program that can run and manage the lifecycle of these machines. This program is called a hypervisor. And the hypervisor is in charge of virtual machines. It manages the lifecycle, it starts them up, it stops them, it creates them, it deletes them, it provisions resources for them. That is what the hypervisor does. Now, a common hypervisor that you would be aware of is VMware or VirtualBox. These are the programs that control the virtual machines.
Oh, okay. Well, I think when it comes to, yeah, okay. I thought he was gonna say Firecracker, because that's the one that AWS uses, or at some point used, for virtualization. I don't know if they're still fully invested in the Firecracker VM at this point. I feel like I read somewhere that they've moved on because it was starting to not be adequate in terms of performance. I could be just completely hallucinating this, but I get the sense that I'm not sure if AWS is still 100% invested in the use of hypervisor on their own infrastructure. I know it's open source and it's adopted by many platforms. Yeah. I think Google has gvisor, and I think one thing that sets gvisor apart from Firecracker is the fact that it has GPU support, and in fact, I think recently Modo Labs opted to go with gvisor for their virtualization stuff. Yeah. Compute jobs are containerized and virtualized using gvisor. OpenAI is using it. Scout is using it. I mean, all of those companies are obviously great signals. I mean, Google uses it themselves. So, yeah. Okay. So yeah. Cloudflare. For some reason, just now in my head, I was thinking, wouldn't Cloudflare have their own virtualization thingy? But I mean, why? I mean, why if you can just use what Google has done or Amazon has done? Why would you invest so much time into building your own hypervisor? Except when you are antithesis and you need to do a virtual. Oh gosh, I'm still not used to this keyboard. And you basically decide to build your own hyper. Well, they didn't build it from scratch. I think it's based on an existing one which they retrofitted to basically make it oh wow, this is actually, I didn't know about this. This is a big deal. In fact, I wouldn't be surprised if Palantir acquires them. It's the kind of thing that I can see happen. Because, I mean, if entities if the software works the way they advertise it and it's super solid, I can totally see a company like Palantir or MongoDB just acquire them. I mean, the guys who made this are the same guys who made the Foundation DB, which got acquired by Apple. And Apple still uses it today for the whole iCloud infrastructure. At least the configuration management of it. I don't know if it actually handles the data plane stuff as well, like the actual user cloud data. But I know that it's still very much in use at Apple. Snowflake uses Foundation DB. So yeah, I don't know how much longer entities stays and these entities is without being acquired by some big player if the software works the way they advertise it to do. To be, which, I don't know why it wouldn't, because they've done such an impressive job with Foundation DB that they have that clout basically built in. Anyway, let's get back to the original thing, which was Kubernetes, but at a more introductory level, Docker stuff. Just a vibe, instead of just jumping right into Kubernetes. Just let's roll back and quickly talk about Docker.
Now, virtualization is similar, but it differs from containerization, which is the thing that Docker is kind of based around. So let's talk about containerization. In a container setup, what you would do is you would have a host PC, much like the virtualization setup that we set up before. Now, let's say on this host PC, we want to run a set of processes, but we want these processes to run in isolation. We don't want them to touch anything else. Now, we can achieve that using some techniques, right? Let's say we want these processes to run on this machine, processes. What we do is we can use some techniques like the chroot command, which will create a new root for a process, so it can only live inside that root, and it can't touch anything outside of that, like any of the other user directories or things like that that are already on the system. We can also use a kernel feature, like the limit feature, which will limit the amount of resources these processes take up. These techniques, amongst other things, will encompass what is containerization. Now, with containerization, you can do all this manually yourself, but it's really difficult and pretty tricky. So there are programs that help manage the lifecycle of your containers. This is where Docker comes into play. Docker is a program that manages the life cycles of containers, edit them, run them, and interact with them. So to sum up, containerization is the ability to create a lightweight environment where processes can run on a host operating system. They share all the same things in that operating system, but they cannot touch anything outside of their little bounded box. Okay, so we've talked enough about virtualization and containerization. Let's see containerization through Docker in work. Let's get our hands dirty. So now let's install Docker. Again, this is this portion of our graph right here. This is the management layer that will manage the life cycles of all of our containers that we want to create. That's what Docker does for us. Now to install Docker, there are examples of how to install it on the Docker website. For me, I use Arch Linux, by the way, so I'm going to use Pacman to install Docker, and it's as simple as that. Docker is now installed. So how do we know that Docker is even running correctly on our system? Well, Docker gives us a helpful command that we can run to sort of give us our first taste of what Docker will do for us. We can do Docker space run space hello hyphen world. Let's see what happens. We're gonna break down this command.
Actually, yeah, let's see what I get. Docker run hello world, because I just installed it. Yeah, okay. Screwed. Let me see. Yeah, even though I just installed it. Ay. Oh, wait. Can I just... How do I make sure that the Docker daemon is running? Can I just do Docker info? Well, okay, I know it's not running, but can you give me some guide on how to get it running? Can I get that just from the CLI itself, or do I have to go Google for this? I know something is probably screwed up with my installation, but this is just me trying to see if just by using the CLI I can get it to somehow work. Okay. How to get the Docker daemon running. Start the daemon sudo syscode. Yeah, okay. Well, this is fun. We're learning things. Is this not available on Mac? I want to install Docker Desktop. I feel like that's the one thing I want to avoid above all else. I just don't like it. All right, we're learning. Yeah, I guess I could install Kolima, but that's not really what I want to do now, is it? I don't feel like, well, I guess I could actually do that. Why didn't I actually try that before? Okay. Actually, let me see if I can do this first. It's already installed and up to there. No, I don't want to reinstall. I thought I typed uninstall, by the way. Okay. So now if I do this, okay. Now can I do reinstall Kolima? Is it just 1L? I feel like I already asked that question before. Oh boy. Yeah, that didn't work either. I think I did something that basically, yeah, something is wrong with the way I set things up on this computer. Because things are supposed to be isolated, but they're not really. Like changes that I'm making in the other account are directly affecting how what I cannot do on this account, which I did not anticipate. Skill issues. Okay, so we're not actually gonna follow through with the specific commands that this guy is running. Again, derped real big for this stream. I should have have my ducks in a row, as they say. But I think I'm gonna handle this by the next stream that we do on Kubernetes stuff.
In a little bit, but let's just see what happens now. Okay, a lot of stuff just happened. Let's go through this line by line and let's see what Docker is telling us that it did. Now to start off with, Docker was unable to find the image hello world latest. Now this is the name of our image and this is the tag of our image. Now in Docker speak, an image is basically the thing we run our containers from. I'll explain again in a second. And latest is the tag of that image. By default, Docker tags its images with the latest tag. So Docker was unable to find the image hello world latest locally, so it pulls it from a repository. Docker will pull images that are already known from Docker Hub. We can actually check out Docker Hub by going to hub.docker.com. And this is where you can see all of the images that Docker already has pre-built in this platform here, Docker Hubs. This is where you can explore. If I want to look for, like, let's say a Postgres image, here it is right here. I can use the Postgres image from Docker Hub. I don't have to build one myself. So Docker Hub is very helpful, and that's what it does here. It pulls the hello world image from Docker Hub. And as you can see here, it says status downloaded newer image for hello world latest. Awesome. And then it says hello from Docker. This is the actual image running a container. I'll explain this in 1 second here. This message shows that your installation appears to be working correctly. To generate this message, Docker took the following steps. The client contacted the Docker daemon. The Docker daemon pulled the hello world image from Docker Hub. That's what we were just talking about. And then the daemon created a new container for us from the image. Okay. And now the Docker daemon streamed that output to the Docker client, which sent it to your terminal. Okay. Let's unpack this a little bit. You might be asking yourself, what the hell is an image, and how does Docker know how to build these things and run containers from images? What is all this stuff? Now, before we talk about how to build images and how to then run containers from the images, we have to talk about something called a Docker file. This is an example Docker file, and it's pretty contrived, but essentially what you would have with any project, anything you want to build an image out of, is you would have a directory structure that looks something like this. In this contrived example, we have a directory that contains a Docker file, and within the Docker file, we have a coffee recipe folder. Let's just imagine that this is a coffee recipe application of some sort. In this coffee recipe folder, we have 2 scripts: prepare beans and brew coffee. Okay, so now let's talk about what this Docker file is doing. You can see on this very first line, we have from Ubuntu latest. Now you might remember this terminology from not too long ago. That means that we want to use the Ubuntu image at the latest tag. This is the terminology for an image and the tag for that image, Ubuntu latest. Okay, great. The next line says we want to run apt-get update and apt-get install some contrived package. What is this? This line tells Docker that we want to run something on the image that was added above. So we're running apt-get update and apt-get install on our Ubuntu latest image. So this runs commands on the image. Next, what we want to do is copy the coffee recipe directory from our local file system into this image. So what we want to do here is basically just copy things from our local directory. Again, you can remember our directory structure looks like this. We have the coffee recipe directory, and under this we have a couple of scripts. So we want to copy the coffee recipe directory into this image. Next, we want to run in our image the script prepare beans.sh. So this will run that script. Now remember, since we copied the directory into our image, we will have.
Wait. Sorry, I was distracted there for a second. Somebody almost came in, so I had to tell them I was on stream.
This line tells Docker that we want to run something on the image that was added above. So we're running apt-get update and apt-get install on our Ubuntu latest image. So this runs command on the image. Next, what we want to do is copy the coffee recipe directory from our local file system into this image. So what we want to do here is basically just copy things from our local directory. Again, you can remember our directory structure looks like this. We have the coffee recipe directory, and under this we have a couple of scripts. So we want to copy the coffee recipe directory into this image. Next, we want to run in our image the script preparebeans.sh. So this will run that script. Now remember, since we copied the directory into our image, we will have this available to us because preparebeans is right here. Oh look, I misspelled it. How fun. And then next we have this line that says command. Now command is the default command that this container is going to run. This can be overwritten in the CLI, but by default we're going to run the brew coffee command. This is the default command for our Docker image. So when the Docker container runs, it's going to run this default command. So now let's zoom out a little bit here. What we are going to do is we are going to take, in this contrived example, this Docker file, and from this Docker file, we are going to build a Docker image. Now this image we could name anything, but let's just call it coffee, right? This image by default will be called coffee at the latest tag. You can give an image whatever tag you want, but again, by default, Docker gives a tag of latest to every image. Now this image is almost like the file system for the container to run, and it's immutable. You can only build one image. You don't change your images. What you do if you want to change anything is you change your Docker file and then build a new version of your image for containers to run. Now from our image, what we want to do is we want to call Docker run, and that will then run our container. And our container, as we said before, will call the run command that we specified in our Docker file, which was brewcoffee.sh. And again, to actually build the image, we want to run docker build. And there are certain flags we can pass to build, like I said, to change the tag of the image from the default of latest. You can also name the image whatever you want, but this is generally the process for Docker. We want to create a Docker file in some repository or in our directory. We want to then use this Docker file as the instructions to build a new image for Docker. Then we can run this image and Docker will spin up a new container on our system that is not able to touch anything else within our system, and it will run whatever code we want it to run using the command flag. So that in a nutshell is how Docker sets up Docker files, images, and containers. Okay, so now we have all of our core concepts in place. We understand the relationship between a Docker file, how a Docker file is the instructions to build a Docker image, and then how a Docker image is used to then run a Docker container, all underneath the umbrella of the Docker CLI. So let's get our hands dirty and actually try out a real world example. This is going to be a simple example. It's a contrived example yet again, but we're actually going to run a real container on our system to get a feel for how the Docker CLI works. Now let's just say I have a directory called Docker example, and in this directory I have two files, a Docker file and a printmessage.sh file. Let's take a look at them. Let's start first with our printmessage.sh. We can see that it is a bash script, and then it has a variable that has a list of phrases. These phrases are then randomly selected, and we print them out to the terminal using a program called Figlet. Now, what if I don't have Figlet installed on my local machine? Well, that's okay. That's why we have this Docker file. So in our Docker file, what we want to do, as we've seen before, we want to use Ubuntu latest. That means we're using the latest version of the Ubuntu image from Docker, probably from Docker Hub. Then on that image, we want to run apt-get update and apt-get install Figlet and wget. We're going to use wget in the next line where we run wget and we wget some fonts that we want to then install on our system. Then we want to copy our local print message script into the container for printmessage.sh. This is what we're actually going to run. Then we want to chmod plus x printmessage.sh. That just makes this script executable inside of the container. And our final command is to just run printmessage.sh. It's a pretty simple Docker file, but this will give us an understanding of how to use these things in real time. So now that we're within this directory that has a Docker file, we can call from within the directory Docker build. Now in Docker build, we could tag that. By default, it will tag it with the latest release, and we can call this ASCII. And we want to make sure we build everything in this current directory. This will build our very first image. Let's see what this command does. Okay, this was a lot of stuff, but let's just go through it really quickly and see what we did here. We can see that it sent the build context to the Docker daemon, and then we did the steps that were in the Docker file. We can see the Docker file working for us. Step 1 out of 6 from Ubuntu latest. Now it pulls from library Ubuntu. This is probably pulling from Docker Hub. We then run apt-get update and apt-get install these couple of programs onto our Ubuntu image. Very good. We can see that that is running. That's what all of this output is. And then in our next step, step 3, we want to run wget for these files. Now these files were then taken and saved into this image. Very good. And now in step 4 out of 6, we copy our local print message script into the image. And then we run chmod plus x, which will make it executable. And at the very end, we want to make sure our default command is just by running this print message script. Cool. Okay, so now we have our image built. How do we run the container based on this image? Well, what we can do is we can check what images we have currently built on our system with the docker images command. We hit enter, and we can see that amongst a couple others like Ubuntu and Hello World, we have our ASCII image tagged at the latest tag with an image ID created about a minute ago. And that's what we have right here. We built our image. I'm gonna make my font smaller here because we're printing out ASCII text and it's going to be pretty large on the screen. You'll see what I mean in a second. But basically what we want to do is now that we have our image built, we can run docker run and then type the name of the image, which is ASCII. We can also optionally add the tag, which would be latest, and I'll just add it right here. If we do this and enter in this command, we can see that it actually runs the container and it runs the script that prints out ASCII art to our screen. Isn't that awesome? So basically what we've done here is we have now a Docker file that installs things into an image. We have an image that has all these programs on it, like Figlet, wget, and everything else, and then it has a script inside of that image as well. Now the container runs, and the container's default command is to then print this stuff out to the terminal, and that's what it is. We just did that. Awesome. Now we can keep running this.
And I think the key thing to keep in mind here is that, at least what was implied, is that he doesn't actually have Figlet installed on his own machine, and yet he's running a program that depends on it on his machine. And I think that right there is really a good showcase of why Docker is so useful. Or just the idea of containerization of your program.
Command, we can keep running this Docker container and it will just randomly select another thing. Apparently it was the same for a bunch of those, but it will select random things and then print them out in an ASCII text to us. Very cool. But now let's say we want to modify this script and we want to print out different things. What do we do now to update this image? Well, images are immutable. What you're gonna have to do is edit your Docker file and then create a new image, probably with a different tag. Let's get into that. So we see we have our Docker file here and we have our printmessage.sh. Let's just say we want to change some of these phrases. This is fun. I love Docker. Cool. Okay, so now we change the script that actually prints the messages out. What we're going to want to do is build a new image from this Docker file because this new image is going to contain different things. Okay, so let's do docker build -t. And what we want to do is we want to name this ASCII with a colon. The colon is going to denote the tag. And I'm just going to call it different. We can call it whatever we want. And we want to build it from our local directory. Now let's hit enter. So we can see here we get very similar output to what we had before. We probably get less output because we already have the Ubuntu image installed and we already have these programs installed in the Ubuntu image that Docker is using to build this image. But we can see down below we've successfully built this new image which has a new ID and there's a new tag called ASCII different. Very cool. All right, so now let's check Docker images to see what this looks like. Okay, great. We can see we have ASCII's latest build, which isn't currently the latest because we tagged it with something different, but that's okay for now. And we have our new ASCII different tag. So this tag is a snapshot of our Docker file that was built into an image. So now let's run our new image in a container. We can call Docker run ASCII and we want to add the tag of different. Let's see what happens. You can see it pushes out the different text that we did. Now we have different sayings that we're putting out there. Like I love you or I love Docker. Let's make this a little bit smaller so we can see it a little bit better, but I love Docker. This is fun. I love you. These are all the different messages that we put in our print message.sh. Now the cool thing is we still have the previous version of this image. Like I said, they're immutable. You don't change the images, you just create new ones. So we can also say Docker run ASCII latest. And that was the previous one that we built, which has all of these Star Wars things in there. Let's make this smaller. So we can run both of our containers based on the images that we've built. The images are immutable. You don't delete them, you just create new versions of them. Very cool. So what have we learned here? Well, I think we've learned a lot. We've learned about the difference between virtualization and containerization. And we've also learned about Docker as a whole and how Docker files, images, and containers all relate to one another. But this is just the surface of the surface that we're scratching here. If you want to learn more about Docker, like Docker Compose, mounting Docker volumes, or even doing things like port mapping in Docker, then leave a comment down below of what you would like to learn next. And hey, thanks nerds. Docker Compose is amazing. I mean, it's unbelievable. With just a few lines of configuration, you can have multiple services up and running and talking to one another automatically. It's as if I made a party and invited my friends from different friend groups and they all just go along and have a great time together. Now, of course, I don't go to parties and I don't have friends, but I would imagine it would work something like that. Now, this is part 2 on a free YouTube course on Docker called Docker for Noobs. If you haven't checked out the first episode yet, then subscribe, watch that episode, and then come back here. I'll wait for you, I promise. So in this video, we are going to go over Docker Compose, and we're going to break down a Docker Compose file together. I will show you how services talk to one another automatically in a Docker Compose system, and we'll even talk about how to store data outside of Docker containers for our database. And we're going to do this all in a real live application that we're going to build together in this very episode. So this is it. This is Docker for Noobs episode 2. Let's get into it. Now, Docker is an amazing tool for developers. It gives you the freedom and flexibility to develop things in a consistent environment. You don't have to manage your dependencies because Docker will install them all for you, and it's just a great way to work on applications. Docker can even deploy stuff in production, and you can actually ship things with it. But if you have a web application, you probably have multiple services that need to talk to one another. I could think of just a basic example. If you have a Rails app, then you have a web service and a database service. Now, you can't really use Docker independently for these two things. How do you get them to talk to one another? These are individual containers. How do they speak to one another? Well, the answer is Docker Compose. Docker Compose is a tool for creating multi-container applications where services can talk to one another easily and efficiently. Here, let's get into an example. We are actually going to show how to use Docker Compose with a real-world application. It's going to be a simple Ruby on Rails application, but the main tenets can be applicable to any other app that you might be developing for yourself. So let's dive right in. We're actually going to create a new Ruby on Rails application to use with Docker. So we can just write a Rails new command with the Docker Compose. That's the name of our Rails application. And we're going to make sure our database is PostgreSQL because that's what we're testing with. We're testing with our web application service and the database service. And we want to make sure these two things can talk to each other in our Docker Compose setup. So let's create this new Rails project. Okay, so now this project set up. Let's get into creating a Docker Compose file. So again, the goal of this video is to create a Docker Compose solution that can have two services in our web app talk to one another. These services are the web server, which in Rails is Puma, and the database server, which we are using as Postgres. So let's put down a quick diagram of what we're trying to do here. Okay, we are going to have a web service, which in our case is going to be Puma, which is just the name of the Rails server that Ruby on Rails likes to use. And we're going to have a database service, DB. And that database for us is going to be Postgres. So what we want to do is we want to have a system where Docker Compose can launch both of these services and have them basically talk to one another without there being any issues. We also want some redundancy. We want to make sure these services are healthy, and we also want to be able to work on them locally. Okay, so this isn't just for deploying to production. This is for local work. Because what this does is this gives your whole entire team just a much easier setup when it comes to actually installing dependencies and getting to work on whatever project you're working on. Docker will handle all the dependencies for you. So let's get into this Rails app. So the first thing we're going to want to do is actually create a Docker Compose file, which is a YAML file, which will contain all the configuration that we want in the base directory of our application. So we have cd'd into the base directory of our example Rails application. What we want to do is create a new Docker Compose file. Now in later Docker versions, you only need compose.yaml. I think previously it was docker/compose.yaml was the naming convention, but compose.yaml works now. So we create a compose.yaml file. Here's the thing. I could sit here and type out a YAML file line by line and try to explain it, but I think that would take too long and it would be really boring to say the least. So what I'm going to do here is actually paste a whole entire YAML file with everything we need for our setup, and I'm going to go and explain it line by line. I think that'll help with explaining how this stuff works and how all these pieces fit together. Let's paste this YAML file just like that. Now we can start to explain line by line what's happening here. And don't worry, by the end of this, you'll understand exactly what's going on. I'm going to break it down for you. So the very top level of this YAML file, we have an attribute called services. Now this denotes the block for services in the YAML file. Pretty self-explanatory. And we can see that one level in, we have two services here. One is DB, which is our database service, which we explained earlier in that little excellent diagram we just wrote. And the second service is web. These are the two services that we want in our Docker Compose environment, and we want to talk to one another. Pretty straightforward, right? Good. We're going to explain a little bit more about these services and their names a little bit later. So next we're going to dive into the DB service and explain all of these attributes and what they mean. Now the very first line here is the image we want to use for our database. Now if you remember from our previous episode, an image is essentially a built Docker file that we then use to launch a container. So if you remember, this image is going to be the Postgres image with a tag of 16. Our images are specified as the name and a colon and then the tag. So this is going to be Postgres version 16. If we don't have it locally, then Docker is going to look up to Docker Hub, install all the correct things, and we will have Postgres version 16 running in this containerized environment. The next attribute is the environment attribute, and this specifies some environment variables that we want loaded when this container loads. So for Postgres, we're going to need a Postgres user and a Postgres password. But as you can see, we actually don't have values here. We have variables. So what are these things? Docker Compose by default will use a .env file to load variables. So if you want to store your variables in a place that isn't your Docker file, which probably isn't something you want to do, then you can store them in .env as long as it's in the same directory of this Docker Compose file. So we have a .env file right here. And if we open our .env, we see we have a few variables. We have database host, which is for our Rails section. We'll get that in a minute. We have Postgres user and then Postgres password. So this is our env file, which stores all the variables for this system. I'm trusting you guys with this one. Don't copy these down because that is a secure password I use for everything. Now, of course, I'm kidding about the whole password thing. You see, I don't use my passwords over and over again. In fact, here at Typecraft, we don't reuse passwords at all because we have a strong password storage solution thanks to the sponsor of this video, NordPass. NordPass is an amazing password storage and sensitive information sharing platform that is amazing for businesses. So here at Typecraft, we use it all the time, and a really awesome part of the NordPass platform is the ability to set your custom password policies for everyone in your organization. So you can have complete control over how strong your passwords are, and they can follow as strict of a guideline as possible that you want for your whole entire organization. And they also have an excellent Chrome extension. So if I want to go to, let's say, I don't know, our Stripe business account, I can log into Stripe using NordPass using the Chrome extension. You can see right here, it's prompting me to log into NordPass so that I can unlock the password and username autofilling options. Now, I'm not going to actually show my login for our business Stripe account here in this video, but everything with NordPass, the platform itself, the Chrome extension, just data to live on the container. Now, the volume section is the solution. In Docker, a container is something that is ephemeral. So anything that's stored on that container will most likely go away if that container is stopped or deleted. So you don't want any of your precious data to live on the container. Now, the volume section is the solution.
Yeah, actually, that's something that you either figure out. Well, it's one of those things that when you start using Docker, you don't know, and sometimes you learn the hard way. That you want to make sure that when you're working with a container where, like usually database containers, locally or for development, you want to make sure that you mount a volume that persists between iterations. Otherwise, it can be quite a drag to have to for debugging purposes if you don't make sure that your container maintains maintains the state that you need to make to iterate through and debug your local application.
To having data live somewhere else so it is persistent. Let's explain how that works. In this section, we can find the volumes that we want to use for this container. So down here, we see our volume says PG data, colon, and then a path. PG data is the name of the volume that we want mounted into this container, and then the right-hand side of that colon is the path that this volume gets mounted to onto the container. So whenever the container saves some data, like in a database, it actually gets saved to the PG data volume. And you can define your volumes under the volumes section of the Docker Compose file. So we define volumes PG data. So we have PG data defined down here, and then we use it up here in the volume section of our database service. Next, we have what's actually a pretty interesting command, and that is health check. Now, in a multi-service setup for a web application, or any application in general, you want to make sure that all of the services that are talking to one another are healthy or that they're actually running. So that's what this section of our Docker file is doing. We are defining how to run a health check for the database service. So under the health check attribute, we have
and along with that, and if you look in the web section, you then also have a depends on, so that some containers don't start prematurely dependent on other containers in your composition of services. I want to say that I feel like originally when Docker Compose was a thing, that was not part of the feature set right away. But I'm not sure if that's true. I just remember way back when it was kind of a pain to use Docker Compose where you have so many services and there's this, during the height of the craze of microservices, or I guess the hype phase, where everybody's grandmother was building every simple little to-do app into into an application with 12 different microservices and all that. And for local development, you definitely needed to use something like Docker Compose. And I just remember that there was quite a bit of issues around this whole dependency thing. But now I'm trying to remember if that was just skill issue from being very a junior, or it wasn't just me on the team who were having these issues. But I'm trying to remember if that was because we didn't know better or because that specific feature was not already available.
a few more attributes that we need in order to check that this service is healthy.
know.
The first attribute is test. Now test defines what actual command gets run to check if the service is healthy. And we know it's healthy if it exits with a 0. Now 0 is a successful exit code in Linux or Unix systems, and anything else is non-successful. So as long as this test exits with a 0, then we know it's healthy. Let's explain that a little bit more. If I were to just echo out literally something, right, it would print that out onto the screen. Now I can check the previous process's exit status by echoing out $?. That will give us the previous exit status for the previous program that was just run. And for us, since that echo was successfully, it gave us a 0. Okay, great. So if I echo something and then attach another command to it, like something that doesn't exist, it will error out for us. And we can check the previous exit status of that process and see that is a 127. That's a common error code in Unix or Linux systems. And so that is how this health check works. Under the hood, if there's an exit code of 0, it's healthy. And if it's not 0, it is not healthy. And then so what happens after that is that anything that depends on that service for being healthy will also be able to say, oh, this whole system's not healthy. Then you can log stuff out, or you can just turn off everything, or other services will be marked as unhealthy as well. So now let's get back into our compose file. Now there's a couple more attributes that you want for your health check. There's interval, which is pretty self-explanatory. This is the amount of time it'll run every 10 seconds. We want a timeout, and then we want retries. Now this is the amount of times it will retry before it actually says that it is not healthy. If it gets 5 retries of a non-zero exit code, this service is unhealthy. Okay, so now we've looked at one of the services in our setup. It's only 2 services, so we have just one more to go. But this one you'll see is just a little bit different, but we'll explain why as we get into it. Now our second service here is the web service. This is our actual web server. And for this service, instead of an image command, we have a build command. And our build command is set to dot, which is just a path, and that path is this current directory. That's what dot means. But why do we have a build command instead of an image command? Well, our web service is something that we're working on locally. We want to actually develop on our web service. So we don't want to work off of an image that's already been built off of a Docker file. We want something more dynamic than that. So this service gets rebuilt whenever we launch it. And the build command specifies a file path where a Docker file should be. Now in Rails, there's a convention that a Docker file is in the root directory of your project. So for us, we are saying our web service, which is Rails, is going to build from a Docker file in our current directory. And we can see there is a Docker file in our current directory. Now I'm not going to go over the Docker file. Essentially what it does is it builds up a Rails development environment, but that is what we are using to build the image for this service that gets run in Docker Compose. Okay, so now let's go back to our compose.yaml file. And next up we have a command attribute. Now this command attribute is what this service will run after the image is built from our Docker file. So we're going to build our Docker image, which installs Ruby on Rails, installs all the gems and libraries that are needed, and gets everything all set up. And then we run a command which essentially just runs our Rails server. We can see at the very end of this line it says bundle exec Rails s, which stands for server, and then it gives us a base IP to start from, which is essentially localhost. Next up we have the volumes attribute. Now this is similar to what we used in our DB services volumes attribute, but it's got one little difference. You can see right here, instead of specifying the name of a volume, we specify our current working directory, which is dot. And on the right hand side, which is the containers data, it's in /Rails. Now this is specified in our Docker file. If we look really quick, the Docker file to create this Rails environment has a work dir, if I can type directly, a work dir of /Rails. So on the container that is built from this Docker file, the working directory is /Rails. Okay, so what does this do for us? Well, let's explain. So in the database version of using volumes, we name a volume called PG data, and then we mount that volume onto our container at a special file path that is specific for Postgres. So in our web service, what we're doing is we're taking our current working directory as if it was a volume and mounting it into the Rails directory of the container. Now this is amazing because what happens is when we make changes to files in this directory, in this project, they get loaded by this service. This service has a folder called /Rails that is just this current working directory on this local machine mounted at that position. Next up, we define ports. Basically under ports, this is just port forwarding. Now Rails runs at the port of 3000, and so what we want is to forward our local port of 3000 to this container's port of 3000 so that it just kind of seamlessly runs locally on our machine. We don't have to do anything crazy to actually connect to this Rails service. It kind of just feels like it's local for us. And then we get to a very interesting attribute called depends on. Now this is going to refer back to our health check that we made for our database service. What happens here is we depend on our database service that the condition is service healthy. So if the database service is ever unhealthy, then this service, the web service, will also be marked as unhealthy. That's why we make sure these multiple service environments are all working correctly. It's not like this Rails service is going to run when the database service is down. If the database service is down, the Rails service will also report that it is down as well, which is really great to have in a multi-service environment. And last but not least, we have an environment attribute for our web service, and this just contains a few environment variables that we need in our Rails environment. Nothing really too crazy here. This is just something that Rails needs. Okay, so now we've gone line by line down our Docker Compose YAML file and explained what each attribute does. Now let's actually run Docker Compose and see how we can get these services talking to one another and just see how the system runs. So once you have a Docker Compose file in your current working directory, all you have to run is Docker Compose up. This will spin up every service in that Docker Compose file, and if it doesn't have the image that it needs, it will download it, it will install all the dependencies, and it'll do all the things for us. Let's see what happens here. Now, of course, you can see that this is my first time running it, so we are downloading all these libraries, we're downloading our database service dependencies and our Rails service dependencies, and we're getting everything set up. And we can see here that everything is set up. It looks like our Docker Compose file worked. We have 2 services. We can see here that we have a DB service and a web service on the left-hand side here. We can see these 2 different services, and they're up and running. Okay, so everything is up and running, but how are these things talking to one another, and are they talking to one another? Can we check that out? Actually, yes, we can. But first, let's explain how these services talk to one another in Docker Compose. So as you saw, we said before, we have 2 different services here. We have the database service, and we have our web service. And Docker Compose kind of encapsulates all of these services.
Yeah, it basically creates some internal network that where every container within the network with assuming that they have exposed ports, they can then talk to each other. But I think by default, you I think by default you can't just connect to containers within that network. I think you need to do something extra to get in. So for example, if a container is running at localhost 3000 within that internal network, I think there is some, but I mean, isn't that what the port expose is for? Because I think when you do the expose, it means that it's exposed via localhost. It's actually something that my understanding is not as clear as I thought it was. Because I know there's a separation between the internal network of the Docker Compose thing, and then there is the local host thing. And when you run an instance, a container image within the network, maybe it's just the exposing the port is what allows it to escape outside of the private / internal Docker Compose network. But now I'm wondering, let's say that you didn't care about being able to ping it from localhost, right, from outside, and it was just enter container communication. Do you still need to expose the ports within the network, or there's a mechanism for? I would think that you still need to. If not, then you need some sort of address that a container can use to talk to another container within the same internal Docker network. Maybe he'll go over this here.
Services together for us, okay? So this is our Docker Compose environment. So how does our database service actually talk to our web service? Well, what's really interesting is that Docker Compose has its own internal network, and it also has its own DNS. So our DB and our web service, as you can tell from our Docker Compose file, were named DB and web. So these names are recorded in the DNS for this Docker Compose setup. And so what we have here is a DNS that maps our DB service to the correct port and our web service to the correct port. So when our web service wants to talk to the database service in order to store some data or whatever, it goes through the DNS and it talks directly to the DB through the DNS of Docker Compose. So web doesn't have to know any kind of special IP for this database. It just needs to know the name of the service, which is of course DB. So our web service, all it has to do to connect to the database is use this URL, db:5432. Now 5432 is the default port for Postgres. You can define what port you want it to use, but that's the default. And this makes it so much easier for these services to communicate with one another in Docker Compose. Now let's see this in action. So first things first, we have our Docker Compose spun up right here. We have all the logs, but I kind of don't want to run this where it takes up my terminal window here. So let me Control-C out of it. And what you can do is you can pass the D flag to make it run in a detached state. So it won't take up your terminal. So if we run Docker Compose up-D, it will run in detached state. We can see that our web service was up and running. And actually what's interesting here, you can see the order of events. It waits for the database service to report that it's healthy before the web service is started, which is pretty cool. So now since it's in detached state, we can actually control our terminal again. Now, of course, if you want to see the logs for these services, you can just run Docker Compose logs and then the name of your service, and you can see your logs. And then you can also do -F if you want to tail those logs and whatever. So now let's get into our web service and just check how it communicates to the database service. So you can run something on a Docker container in Docker Compose by typing Docker Compose exec. This will execute a command on a container. Now we can type the web service and then the command we want to execute, which for us is going to be bash. So Docker Compose exec on the web service bash. So now we're in a bash environment in our web service. You can see that we're actually at our mount point for our volume, which is /rails. Pretty cool. So we can type curl db:5432 to see if this communication line is set up. And of course it is. I know this looks like maybe it isn't, but it got an empty reply from the server because Postgres doesn't have just a reply that it'll do to a curl request. So we know that this communication is up. Now we can check if we do just curl something, that's cannot resolve host something. So when we type curl db:5432, we can resolve that through our DNS lookup to the database service, and then the database responds with empty reply. I don't have anything for you, which is awesome. So now we can see that these two services are.
So it sounds like you still need to expose the port, even for internal networking purposes. But I'm still not clear if you could just go in a browser and then type localhost 3000 if you have an application to talk to the to connect to the Rails app, which is running on 3000. Yes, I know I can just look this up or ChatGPT it real quick, but I'm just trying to, because I could have sworn that I was sure. Like what? Because it's basically what I'm hinting at is that there is a hierarchy or some sort of setting or configuration that you need to do to, again, in terms of hierarchy, so you expose the port and services within the network can talk to it, and then there is also being able to talk to it from outside of the internal network. And I'm just wondering if exposing the port on the container enables both at the same time, or enables the former, which is just internal, and then you have to do something specific to be able to enable the latter, which is from outside the internal network. Yeah, I could have sworn there was something extra you had to do. I just can't think of it right off the top of my head. Or maybe there isn't, and I'm just confounding things.
Communicating seamlessly with one another. Okay, so I said we'd actually work on this web environment together and actually work on an application. Let's do this now. This is a Rails application, so let's just make, I don't know, something simple like a blog post and just check that we can save things in the database in our database service and that our web service responds correctly to web requests, namely, the browser. So we remember that we actually launched our Docker Compose in a detached state. So if I want to see the logs for web, I can see that, yep, web is currently up and running. So if I go to my browser, if we go to localhost 3000, of course, we see the Rails splash screen. That means that this is a new empty application.
So this answers my question. I think by exposing the port, you get access both from inside the internal network, but also from outside, from localhost. But then how do you how to prevent localhost I think this is it. I might just ChatGPT this. I don't care about outgoing. I'm talking about incoming. Do I have one of these open? Okay. How to prevent access to container from outside Docker Compose network. The things you think you know until you realize, wait a minute, there are some details here that I either forgot or never truly fully understood. Okay. without exposing port. Okay. Bridge. Within the internal net. Okay. Okay, so yeah, this makes from localhost, so no ports. Okay. No external access at all. When using an internal network, what should the containers use configure as address for other containers in the same internal network? I don't know if I phrased that question the best way. Because, for example, for the Rails app, you probably have some sort of environment variable, right? That says which database to connect to. When you do the internal thing without exposing a port, I don't think you can just point to, Postgres localhost 5432 and then database name or whatever. Yeah, I think you have to use a maybe I'm wrong. No, I'm right. Yep, you don't use localhost. You actually use the service name or the container name. Well, the service name. Yeah. Okay. Yeah. Okay. So when you don't expose the port, you just want to keep the things internal for whatever reason. I don't know why necessarily you will need that, but you might, even on local development. Yeah, okay. So I'm glad that I was able to reaffirm or dismiss some reaffirm an understanding and dismiss misunderstandings around this. That's the whole point of these streams. Learning.
That is correctly running for Ruby on Rails. Perfect. So that means that our web service is up and running the way it should be. So let's create a new feature in this Rails app, right? We want people to be able to create blog posts, okay? So with Rails, we can use something called a generator to generate some views and some database migrations and also controllers in their actions, so that with one command, we can put together all of the necessary framework for having a user be able to create posts. Now we want to do this on our web service because our web service is currently connected to our database. So let's go ahead and run this now. We want to run docker compose exec on the web service bin Rails generate scaffold, which is the thing that will generate all the stuff that we need. And we want to generate a scaffold for a posts model. And each post can have a title, which is text, and content, which is also text. Okay, so now we have generated all the things that we need in Ruby on Rails to be able to see posts and create posts and do all that stuff. Now if we go back to our browser and we go to /posts, Then we see here, there's actually a good thing that migrations are pending. So we have to run bin rails db migrate. So what happened here is Rails generated the schema that is needed to actually create a post and to view posts and all that stuff, but we didn't actually run the migration in Postgres. So this is our web service telling us that we need to run a migration, and this migration is going to happen on the DB service. So let's see if this can work. This will tell us if our Rails environment is correctly set up and communicating to our database environment. So to run a db migrate, we want to run docker compose on our web service, bin Rails, and again, this is coming from our error here. It says we need to run bin Rails db migrate. We run db migrate, and I forgot we actually want to have exec here. So it's docker compose execute on the web service bin Rails db migrate. Let's see how this works. Okay, great. So Rails has now migrated our database, meaning it created a schema for posts in our Postgres database. So now the schema is in our Postgres database, and our web service seems to be talking to our database service seamlessly through docker compose. So now let's see if we can create a post with our newly scaffolded post framework now, okay? So we're at our browser, and we can go to our posts endpoint. And we see here that we can create a new post. This is part of, again, this is a very Rails specific thing. Rails will generate all the views, all the controller actions, and the database migrations, and all that stuff for us so that we can just sort of play around with it. Now let's see if we can create a new post. And of course, we have a new post, and this is picked up by the Rails model. It knows that we have a title and content. So this title is going to be some post, and the content is going to be Rails is awesome with Docker Compose. So what's gonna happen when I click on create post here? Well, our web service is going to have this action in a controller. The form will submit to that action to create a new instance of a post in our database service in PostgreSQL. So when we click create post, it will traverse all these things and create a post in our database service. And there we go. The post was successfully created. So now if we go back to post, this is our index, and now we can see that our Rails application is correctly creating and fetching posts from the database service in Docker Compose. So this was a simple but effective Docker Compose file that was able to spin up multiple services and have them talk to one another seamlessly. Now, if you want, I have a repository linked down in the description below, so check that out and make sure to subscribe for more Docker, Vim, Linux, and other tips and tricks. And hey, thanks, nerds.
All right. That was a good overall. The two videos combined. It was a good overall introduction slash very basic entry into the Kubernetes world. I think, Docker, then from Docker you have Docker Compose, and then eventually I think from Docker Compose you have Docker Swarm, if I remember correctly. I don't know if Swarm came at the same time as Compose or came after. Anyway, and then from there you get to Kubernetes. I'm not saying that it's straightforward and linear like that. I know that there was a system called Mesos, still being used by some people these days. But for all intents and purposes, Kubernetes won that battle. I think Mesos came out before Kubernetes. Yeah, why did Mesos lose to Kubernetes? That was not a satisfactory answer. To the question of why Mesos lost to Kubernetes. But anyway, that's my understanding of the path of, the progression, so to speak. So Docker Compose, Docker Swarm, and Mesos, but then people were like, actually, we like Kubernetes, and so the rest is history, I guess.
Travis.media. So I get this question regularly from developers and other IT professionals. What is Kubernetes? Like, they haven't had to do anything with it and they just don't understand it, and they want a concise answer from me. And as you know, there's not really a concise answer for this. It's a loaded question. So I decided, instead of fumbling through a bunch of words trying to give a concise answer, I'm just gonna create a video that I can point them to. And also, if you're new to it or are trying to learn Kubernetes in 2024, then you'll find this video beneficial as well. It's not gonna be just a bunch of diagrams. I'm actually gonna show you the tooling itself. So with all that said, let's get started. So to understand Kubernetes, you must first understand containerization. A container is a standard unit of software that can package up your code in all of its dependencies so the application runs quickly and reliably from one computing environment to another. So you have an application, like here I have a default Next.js app, and you'll create a blueprint for how your application needs to be run. And you'll use something like the Docker engine to build that blueprint into an image. So for example, this application, here's how I'm gonna build it. First, I'm gonna grab node, I'm gonna create a directory called frontend, I'm gonna copy my package.json and my package lock into that directory, I'm gonna run npm install, then I'm gonna copy all of the code over to it, I'll expose port 3000, and I'll run npm run dev. This is my blueprint for running this app. It includes all of the code and all of the dependencies. To build this into an image, I'll run docker build, and I'll tag it as sample app, and I'll build my image. And Docker has built my image. Using VS Code, you can look here under images, and you'll see I have a new image called sample app. So now anyone with this image that I built can then run it, creating a container housing your running application. You can take the image, run it as a container. 10 other people can take the image and run it as a container as well. And every time it's run as a container, it includes everything needed to run that application, and it spins up the same every time. No more, well, it works on my machine, because it works everywhere. It has everything it needs to run on its own. The container is lightweight, it's standalone, and you can...
Well, in theory. I don't know, I feel like there's still a one of scenarios when even with the same container, you still can get an issue where things don't work seamlessly going from one host machine to the other. But theoretically speaking, yeah, this is a non-issue.
And spin it up in a second, you can destroy it in a second. If it crashes, just spin up a new one. In fact, if you go to Docker Hub, there are thousands of images pre-made that you can pull down and use in your container. Like here's Alpine, Nginx, Ubuntu, Python, Redis, Postgres, and they're all public. And they'll run the same on everybody's machine. It's amazing technology, and any app can be containerized. So the sample app, I can just run the Docker run command, or here I can just right-click and choose run. If you look up here, my sample app's running. If I open this application on port 3000, I should now be able to see this app running in the browser. And with another click of the button, I can stop the container. And if I need it to run again, I just run it again. This is great, but what do we do with this now? We spin up a container, we run it on a Linux machine, or in AWS. What if it crashes? What if we want to containerize our front end separately from our back end and have two containers? What if Tiger Woods is winning the Masters on a Sunday and our container gets overloaded and we want to quickly spin up 5 more instances to evenly distribute behind a load balancer, and then when the game is over, kill 3 of those instances so that we can scale back? How do you orchestrate this process of deploying, managing, automating, and scaling containerized applications? Well, you can use an open source solution called Kubernetes. But before we get to that, let's hear a quick word from today's sponsor, Cast AI. So Cast AI is the leading all-in-one platform for Kubernetes automation, optimization, security, and cost management. You simply deploy a lightweight, read-only agent onto your Kubernetes cluster, and from there, you get 3 free features that work within 60 seconds. First, you get a savings report telling you how much you could save by optimizing instance sizes and types based on your usage. 2, you get a cost monitoring dashboard breaking things down over time by tags, labels, namespaces, etc. And 3rd, you get a security report that scans your cluster for vulnerabilities and automatically prioritizes the fixes. And that's all free. If you move to a paid plan, then you get much more. You can set automation, and it will, around the clock, monitor your cluster and rebalance pods to optimal configurations. And of course, like with any secure product, you remain in control with Cast AI's policies that allow you to specify rules and limits. And you continue to see your savings and changes made as your cluster gets upscaled and downscaled. It will even utilize spot instance automation with fallback that moves you back to on-demand while there's no capacity. And it's free to try out. Why not? But check this. If you use the link below, you'll get the paid optimization feature that I just mentioned for free for your first cluster. So check out the link below to take advantage of this deal today. Back to the video. All right, the second part is Kubernetes itself. So here's a diagram from the Kubernetes site. Every Kubernetes cluster has a control plane. That's what's in this rectangle here. I like to call it the master node. This node is its own Linux environment and can be either a physical or a virtual machine. It's the central point of your cluster, and it contains all the system components that make Kubernetes work, like the API server that exposes the Kubernetes API to us, the etcd key value store for your cluster data, the scheduler, the controller manager, etc. And don't worry about what all of these mean. Just know that they make global decisions about the cluster, and you don't...
And I think we went over this in the very first video of this series. And yeah, the control plane, one of the key takeaway was that for the control plane you need at least 2 f plus 1, where f is the number of failures you're willing to tolerate or nodes you're willing to tolerate. So at the minimum, you want 3 nodes for the control plane, right? If you want to tolerate at least 1 failure, or 1 failure. It's irrational. Well, yeah, I would say irrational. Unless you're running something locally for prototyping or whatever. It's irrational to set f equal to 0, meaning no failure. And so you only need 1 node. So I don't even know if I don't think you can, at least for something that's running in production, that's not something anybody does. So yeah, that's where the 3 minimum nodes required for the control plane comes in. And if I remember right, there are 4 components again. So you have the API server, you have the etcd storage engine for the state, you have the controller manager, and you have the there's something else. Shoot. What was the 4th one? Shoot. Wait, where is it? I feel like I had it. somewhere. Yeah, okay. The scheduler, yes. How could I forget? The scheduler. Arguably the most important. I think if you had to rank them, I think it goes scheduler, etcd. I think API server and controller manager are joint third. I think. Anyway.
You don't normally want your applications running on this master node. It's reserved for system components. Instead, you deploy your applications on worker nodes.
I'm actually wondering how big of a cluster can you run from a single control plane? Yeah, etcd is a major component of scalability. Should not exceed 250 nodes. Gosh, why is it so slow? Wait, so how does a company like Uber run a 1,000 plus Kubernetes cluster do they have multiple control planes? Yeah. So it's basically some kind of sharding, and then you load balance between the different cluster federation. Okay, well, I don't want to get too deep into this. This is still going. That's something to revisit at some point.
Which are just additional Linux machines. If you look here at this red hat diagram, here's your control plane, here's the API server, the scheduler, controller manager, etcd. That's your control plane, that's one Linux machine. Then you have these worker nodes, these additional machines that house your applications. And each worker node has a kubelet, which listens for instructions from the kube API server. It serves to deploy and destroy containers, among other things. And each node has a kube proxy, which allows services to talk to other containers on other nodes. And when you want to deploy an application, it runs as a pod on the node. And inside of that pod is your container, or multiple containers, if that's how you want to set it up. But usually there's one container in a pod. And depending on the size and capacity of your machine or node, you can have many applications running on it. And then when that one gets maxed out, you can update the cluster to deploy a second worker node and a third worker node, however many you need. And finally, you can interact with the Kubernetes cluster by talking to the API server. And the easiest way to do this is to install the kubectl CLI. Let me show you how you can spin up a cluster for yourself right now on your computer and get hands-on with it. So we're going to download Minikube today. If you just go to Google and type in Minikube, or if you go to minikube.sigs.kates.io/whatever, just go to Minikube, Google it, and you'll end up here. I'll just put a link below, maybe that's easier. But you want to install this. So choose your operating system, your architecture. I'm on a MacBook, so I would just do homebrew, like brew install Minikube, probably the easiest way. And you'll need to make sure that a container or a virtual machine manager is also running, like Docker. That's the easiest to get started with, in my opinion. So you also want to download the Docker desktop. Just go to docker.com, look for Docker desktop. Once that's downloaded, run it, and you'll be good. And then the final piece you'll need is the kubectl CLI. So just type that in, kubectl. You'll get to this page and choose install kubectl on your system. And this isn't just for our demonstration. You'll actually be using kubectl on all the Kubernetes clusters you'll ever use. So just go ahead and do it. So with Minikube installed, I can do a minikube start command. This is going to start a cluster on my machine. All right, so now that we've done all this theory, what does this Kubernetes cluster look like? So with Minikube, there's only one node, the master node. You have to do everything on that. So with kubectl, I can run kubectl get nodes. And you'll see I have one node called Minikube, and it's the control plane node. If you want to see what pods are running on the machine, you can do kubectl get pods. And Kubernetes has namespaces, so I'll do a -A, capital A, to get the pods from all namespaces. And you'll see all of my system pods. These are the pods, or the system services that are running on this control plane. So you'll see here's etcd, here's the API server, controller manager, scheduler, things like that. So now, how do we deploy applications onto this cluster? Well, we can do that in a number of ways, but the most basic is called a Kubernetes deployment. It's a Kubernetes deployment object. Now with Kubernetes, we can declare in YAML the desired state of our resources, and Kubernetes will work to guarantee that state. So we give it the end product, and it'll do its magic to maintain that state at all times until we change it. So if I go to Google and type in Kubernetes deployments, you'll go to the deployments page. And what's neat about the Kubernetes documentation is that they always have some great examples. So here you can read about deployments, and we get to this section called creating a deployment. The following is an example of a deployment. Here's the YAML, and you're declaring the end state of your deployment, and Kubernetes is going to put it together for you. So this deployment object has an API version. All the objects have an API version. The kind is deployment, and the metadata. So this deployment is going to be named Nginx deployment because we're going to be deploying some Nginx pods. The replicas states that we want to deploy 3 pods of this application. But down here at the bottom, you get to this container section. So within this pod, we have containers. And in this pod, we're going to have a container called Nginx. The image, what it's going to pull down from Docker Hub, is the Nginx container. Here we can take our own application, push it up to some image repository, maybe a private Docker Hub repository, and we can put our image in there and pull down our image. And then it's going to use the port of container port 80. So let's copy this deployment object, and I'm going to cd into my desktop. I'm going to do a sudo vi nginx deployment.yaml. So I'll create a new file, and I'll paste these instructions in here, this YAML into this document, and I'll save it. And to apply this declaration, or manifest as it's called, to my Kubernetes cluster, I can run kubectl apply -f for file name, and then I can use the nginx deployment.yaml. This is going to apply this deployment to my cluster. And just to note, there are also imperative commands, like I can do a kubectl run and then put in the image that I want to use and configure it that way. But for me, I like these things to be placed in version control so that everybody can be on the same page and nobody's making direct changes without being checked in. Just my preference. So when I want to apply this, I just hit enter. Deployment created. Now if I do kubectl get pods in all namespaces, you'll see that I have 3 new pods of Nginx deployment, and the status is container creating. They're not quite ready yet, so let's run this again, and we'll give it a second to create. And now if I run kubectl get pods all namespaces, I'll see 3 new pods for my Nginx deployment. And I can actually do a kubectl get deployments and see the actual deployment object. Namespace is default, and the deployment is named Nginx deployment. So there's 1 deployment, and in that deployment, there are 3 pods. Now what if I want to bump it up to 6 pods? I can just open up my file, so sudo vi, open up that file again, and I can go down here to replicas and change this to 6. And remember, this is declarative, so I'm just declaring my state. So I'll change this to 6. As soon as I save this and run kubectl apply again, it should update that state to now have 6 pods. So let's run get pods, and you'll see I now have 6 pods running. And there's actually an imperative command that I can run to change that replica set, but I like to keep it in a YAML file that I can check into some version control. So I can open it up again, switch this down to 2, and it should kill off 4 of those pods. And I need to apply it, of course. So now when I do get pods, I should see I only have 2 pods. See how quick those are gone? So obviously there's much more you can do. So you can run the back end of your app in a container, in a pod, or 3 pods for high availability, and then run your front end in a separate container in a different pod or set of pods, and then expose it to a load balancer via a Kubernetes service and have a public IP and a DNS and all of that. You can set network policies and all sorts of configurations according to your own or your company's preferred architecture and application setup and all of that. And then as developers, we're updating the code, we're adding new features, and after we commit that, it kicks off some pipeline where a new image is built that can be deployed and ran on Kubernetes. But all of that's out of scope for this video. I can do more on specifics of how any of these things work. Just let me know down in the comments. But if you really want to visualize a Kubernetes cluster and what's going on inside of it, like all of the moving pieces, one tool I would really recommend, and no, this is not sponsored, it's just a tool that I've used a lot in the past, but it's called Lens. So if you go to lens.dev, you can download the Lens desktop. This used to be all free. It looks like there's a pricing tier now, so I'm not sure what the free version gives you. But let me show you how this works. Let me open Lens. And Lens reads your kubeconfig, so it knows all of your environments. So I can click here, browse your local catalog, and I'll see my Minikube environment here. So let's click on that. Let me make this bigger. So this gives you a graphical user interface for your Kubernetes cluster. So here I can look at my nodes. I have one node, a Minikube node. If I had worker nodes, it would show up. I can look at my pods for all namespaces. Here are my 2 Nginx pods that I deployed. Here you can see all of your pods. I can see all of my deployments and different things like stateful sets, replica sets, cron jobs. And then we have a config section, networking, storage, namespaces, all kind of stuff. So if you want to see all of the moving pieces in your Kubernetes cluster with a graphical user interface, check out Lens. It's really the only one I've used in the past and the only one I can recommend. And finally, if you want to learn Kubernetes this year and you're looking for that #1 resource, I've recommended this a ton in the past and I still recommend it. It's a Udemy course called Certified Kubernetes Administrator with Practice Tests. This course is so good. And the reason is this guy runs a website called CodeCloud. So when you sign up for this Udemy course, you actually get to use CodeCloud in their simulated Kubernetes environments to do your work on. So you learn a new concept, you go over there, they give you a terminal, and you practice hands-on all of these concepts. I really enjoyed the course, and I would recommend it. So that's it for today. If you found this video helpful, give it a thumbs up. If you haven't subscribed to the channel, consider doing so, and I'll see you in the next video.
All right. Almost made it. I'm not sure if... Oh, wait. I think I was supposed to keep track of the videos that we watched. Then I can just go in here. Right. History. So there was that one which I only So copy v. No, I need the actual URL. No, gosh, that was dumb. V. Okay, that's the second one. The one we just watched. Wait, it's not here yet. Oh, okay, no, here it is. Just making sure that I add these to the video description. Otherwise, I'm gonna forget.
Docker Compose is amazing. I mean,
I only have that.
My name is James Strong. We're going to talk about
Debating whether I should watch this or the other one. I think we'll watch this.
understanding Kubernetes networking in 30 minutes, or as I like to call the Mario speedrun through Kubernetes networking. My name is James Strong, like I said. I've already done that. I'm a solutions architect at Isovalent now, which is a part of Cisco. I am a maintainer of Ingress and Nginx, so if you have any questions about that, ask me in an hour at my next talk. So I won't be taking those questions. I'm also the author of Networking Kubernetes. I have an 8 Guru course on the same thing, and unfortunately, I could not bring my Gimli cosplay here, but I do have a full Gimli cosplay outfit.
Cool. My name is Ricardo. I'm a software engineer at VMware.com. I have created the Kubebook. I don't know if someone still uses that, like it's kind of broken those days. Like Ingress Nginx. I'm one of the maintainers of Ingress Nginx. So everything that I code usually breaks, sorry. And I
prove it.
Yeah, and I am a Lego enthusiast, so I love Legos.
So today we're going to talk about understanding Linux, Kubernetes networking. But when I was first learning Kubernetes, one of the old adages was that Kubernetes is just Linux. And sorry for any of the Windows folks out there, we will not be talking about that one. And when we say this, I like to bring up this picture I found. This is a great one for the talk. For those who don't know, this is the data flow of a packet through the kernel. So we're setting the bar really low for us. So let's strap in. So agenda, we're going to talk about Linux networking. We're going to talk about what a pod is, what part of it is, and talk about container networking and how we build those Kubernetes abstractions on top of Linux. Ricardo, you want to go ahead?
Yeah, sure. So we're going to start doing some demos in a minute, but I want you don't need to take pictures. You're going to put them on the schedule, I promise.
There's lots of pictures. So.
Yes. So this is how a Kubernetes networking actually looks like. And we are going to actually start building our networking over these with demos and showing like how the routing actually works, why we have a CoreDNS, and what's kubeproxy, and why everyone actually hates kubeproxy.
I can't say anything.
Sorry. Yeah.
So we'll start by talking about Linux networking and what the networking stack is. So the base of every Kubernetes workload is working on a node. A node has an Ethernet interface for external connectivity. We would say it has routing rules, so we know where to send packets. IP tables, so that we can break things with those packets and maybe black hole some of them. And then we have connection tracking. Contract, pretty straightforward name. It makes, it tracks the connections inside the kernel for us. And at very simplistic terms, this is what we would consider the Linux networking stack. It's not everything. There's lots of other things that are involved in this. But for simplicity in 30-minute sake, let's think that this is the Linux networking stack. With that, we're going to talk about how that gets replicated in a pod. And Ricardo wanted to make sure that we talked about this guy, the pause container.
Okay, so whoever actually entered into the node and did like a Docker PS and saw a bunch of pauses and had no idea what the thing was about. Great. Okay, so when you start a pod, you need somewhere to have the network, right? Because a pod is just like a network that is shared between containers. So the pause is what we call the infrastructure container. It's a container that is created just to be there. So you can start creating the other things. It's a container that will be there and won't be on crash loopback or something like that, right? So that's what the pause is. It's just a container that should be started and should be there so you can have network.
And with that, we have containers, so our actual applications are running inside of this pod, and it is part of that pod namespace. But what is that pod namespace, or network namespace there? It is a complete copy of the Linux networking stack. This is what allows us, as app developers, to run something on port 8080 multiple different times. We have multiple applications running on the same port. It's because you have a copy of the Linux networking stack. So if you ever see sometimes when you try to run several copies of Nginx on a host node, you get port conflicts because by default it runs on 80. This is why we can do this inside of containers. And so pods run on nodes, right? We need a node until somebody figures out how to not do that. Even in ECS, you still need a node. And on a node, you have what is called the root network namespace, and that's where, by default, all interfaces go unless you tell it not to. So we've got the container, we've got the pod network namespace. We've also added an interface in there so that we have, again, an interface that runs on there. But how do these two communicate? Again, we have technology called vEthernet. vEthernet is, think of it as just a pipe between the two interfaces. Packet comes in, packet goes out. Packet comes in, packet goes out. And these two are connected by another Linux technology called a bridge. And then, again, we like to reiterate that, all of these commands here are from the Linux command line. There's actually a really good talk, and I think it was reInvent a couple years ago where someone actually, recreated a container with all of these commands. So again, trying to reiterate all this, there's just Linux underneath the hood. And then we wire the bridge up, so now we have external connectivity between our pod network namespace and our root network namespace. And then we have this beautiful picture here. Multiple nodes, multiple copies of the network stack. And I think I'm missing the demo. The demo slide. Oh, you moved it? Oh, see. This is what I get for working with you, Ricardo. So we're going to talk about how all of this works together and how we make those Kubernetes abstractions. I like calling them Kubernetes networking Fight Club rules. And so we talked about the pod container, the two containers talking to each other through that network namespace. And so we get this first rule: highly coupled container-to-container communication is solved by local host communication. So this is a complete copy of the network stack. So these two processes can talk to each other over local host. Pod-to-pod communication. All pods can communicate with other pods with their own IP addresses. And this is, again, worked through with the Ethernet and the bridging interfaces. We haven't talked about services yet, but how to get pod to services communication is covered by Kubernetes service. So again, that's another abstraction. Ignore the fact that Kubernetes is spelled wrong. External to services communication. So everything that we've been talking about up till now has been internal to the cluster. So how pods can communicate with each other, and how the nodes can communicate with each other. So we have to have some way to reach out of the cluster because clusters aren't that great if nobody can actually use them, right? Why are we using them?
At least it's secure.
Is a secure container? A secure cluster has no network. Okay. So we're going to talk about how those nodes can communicate, and we'll let Ricardo talk about pod cider.
Okay, so I will actually start the demo now.
Okay.
Cool. And we are going to understand a bit on these communications and what this means, like one node using the other as a router, and how it works on this pod-to-pod communication being transparent. So we're going to start exploring all of those rules that James did, but using demos, right?
I'll be your mic stand.
Oh, thank you. Cool. So we have kind of recorded before because usually I have problems when I don't record. But the thing that we are actually doing a live demo, first of all, we are using kind. Who knows here who is kind? Oh, that's great. Okay, so whatever we are going to do here and whatever we're going to test here, we want to do in kind because the idea is that you can actually explore at your home later and you don't need to pay like a huge effort of money for any cloud provider just to create a Kubernetes cluster.
I think kind is just another one of those softwares that allow you to run a local Kubernetes cluster, just like Minikube. I don't know if kind is just a superior piece of software, or our Minikube is better. Not sure. Don't know.
Just say like, well, those folks, they are actually right or wrong. Feel free to.
Probably wrong.
Yeah. So Eskinima, well, is it fine, the size?
You guys see in the back?
One more? No?
Good.
Oh, that's good. Okay. If you need, just yell at us. I'm used to it. James keeps saying. Okay, so the first demo that we're going to show here is, I want to show you, I have some Kubernetes pods here. Each of them, they got this IP address differently, right? So this is the pod IP, and let's keep playing here. I want to do a curl, so I went from this pod that is running on this node, on this worker 2, calling this pod running on worker 3, right? And it worked, so we could get hello coupon. And if I take a look into the logs here, I'm going to see that the same address that was from my pod got here. So one of those rules that we got, which was like the communication should be flat, right? It's happening here. Cool. Yeah, so we can see here the IP address that has been used. So let's take a look a bit better on how this, let me just see if I have the right demo. Okay, so pod CIR, okay. How this actually works, right? So again, taking a look into the pods, we can see that we have different subranges here of network, right? So worker 2 has like this 10.244.3, and then worker 3 this 10.244.1, and so on. So those networks, they are kind of segregated, right? And as you can see here, when you configure Kubernetes, when you create a Kubernetes cluster, usually when you are not using a kind, or when you are doing by your own, you configure a directive which is called pod CIR that says, this is the range of IPs that my pods are going to get, right? And that's internally, they are just used for this internal communication. Usually they don't need to be routable for your network, but it would be good that they don't clash with your network as well. Otherwise, imagine one pod trying to call like your service on the same IP, and it's going to actually try to route internally to the server, to the cluster, right? So we can see that the pod subnet here, it's like this 10.244.00/16. And if you take a look into the nodes configuration, we're going to see that each node got this pod CIR spec, saying like, okay, so my worker has this 10.244.
So I'm realizing that maybe this is probably jumping the gun. I think it will make sense to pause and circle back to that video once we get to the networking section of the documentation of the manual, because I think there's some things or words that are being said that will be better assimilated once we've done a walkthrough of the actual manual / documentation. So I'm just gonna pause that. And I'm not so hot on going through this one right now either. And I think we've done a decent I think the stuff that we've watched so far relating to Docker and just container orchestration is fine just for this stream as a placeholder for what we originally intended on doing, which is going through the next session of the manual. Again, the goal was to work on deploying and the app session, basically. I guess all of this will be considered the app session, but I think the goal was to at least go through this and maybe start this. But I ended up finding out that my local setup is just screwed up right now, and having trouble with some installation things. So we did a pivot to watching some interesting content relating to just Docker and Kubernetes in general. But yeah, I think we're gonna call it for today. And either tomorrow or on Friday we'll be back with another Kubernetes stream, and this time around I should have things worked out on my local setup. Yeah, well, thank you for watching this, and if this was helpful or interesting in any way, please do like and subscribe.